this infrared remote control receiver. This is TSOP 4838. So the number is TSOP 4838. It is a remote control receiver, 38 kilohertz. It receives 38 kilohertz, and we're going to test it with a remote control. So here in figure 1, we have this TSOP 4838, 4838. This is the actual. So left side is the signal pin. Then ground, G, ground, S, signal, B, supply. Oops. B is the supply, and it is 5 volts. So B supply 5 volts, ground, G and D, the signal pin. Or where can we have this is an output. So the output, out ground, supply of 5 volts, and this is a receiver. It receives 38 kilohertz. So it means this is already an IC receiver, RX receiver. So every time we have the remote control, when we press the remote, it transmits a signal received by this receiver. The remote control TX is also 38 kilohertz. Okay? So we need the remote that is 38 kilohertz modulating frequency. It demodulates by this 4838 or received by this receiver. Because this receiver is 38 kilohertz also, same as the remote control, if this is the remote control. Okay. We have now a new circuit. So this is our new circuit. This is now the TSOP 4838 receiver. Since this is receiver, we need the transmitter. This remote are all the transmitter. Okay? And our supply is 5 volts. So power bank. 5 volts. Then we have this power LED. You can see we have this LED. And then this whole circuit is a decoder. So it decodes the infrared signal. When I say infrared, our medium for this communication, is the infrared, the light. We can see the infrared here. To test whether the remote is working. The color is purple. So this is working. That is the infrared light. Okay, we could not see that. This one also color purple. Any button, we can press any button, and we could not see this one. We could not see the other one, but they are all infrared, only visible to our camera, not to our naked eyes. So when I press the using any remote. When I press it, it detects a signal because of the light from the remote traveling to the air, then received by this receiver, then decoding using the transistor, and then the output LED with some resistor and capacitor. Let us okay. This is now the circuit with an old breadboard. So whenever we press the remote, as long as this remote is 38 kilohertz, hey, you can see here, must be line of sight. So the decoder detects the signal about this remote Sony. It detects the Sony, the TCL, it detects the TCL remote. So the blinking of the LED is depends on the code of the remote control. So the blinking depends on the coding of the remote. So it has its own codes, different codes. We have 5 remotes working, and these 2 have no batteries. They are all working because they are all 38 kilohertz. So we have now this decoder circuit. We now have the circuit of our decoder. So this is a decoder circuit. So here we have the 5 volt supply from the power bank, and then the power LED. Whenever we have the power, this LED turns on. So just to indicate, we have this power indicator. So when there's 5 volts, it will turn on this LED red, and with the series resistor for 70 ohms. And then this one is now our infrared IR receiver, TSOP 4838. This one is the voltage or the supply, then the ground, and then the signal, the signal pin. This is an out, or sometimes it is in. It depends. So this signal pin, it is sometimes out, also sometimes in. So it depends. And we have this 100 microfarad 16 volts capacitor. We are going to use this capacitor for our circuit to stabilize the supply. So for stabilization. So in our circuit that we don't have this, but we're going to connect, or we will going to use this 100 microfarad for the circuit. And then we have now this transistor. This is BC557 PNP transistor. Emitter connected to the 5 volts. Then the base with 15K biasing resistor connected to the signal pin of the TSOP. And then the collector connected is the 1K with the capacitor again to stabilize the output, and then 10K resistor to keep this transistor grounded. So here, if this is the power LED, we are connecting the output LED here. This is now the output LED green. So this is the again naka-limiting resistor not to damage the LED. This one is green. So this one is the one that blinks every time we have whenever we have this remote control or the remote control transmitter. So if this is our remote, okay, when we press the button, it emits a signal or transmit in the form of a light, or infrared light. As we can see, that is color purple in our last time we see that. And then received by this receiver whenever we press the button. And then since this LED is off, why is it off? Initial state. How about when the time we are not using yet the remote control? The time that we are not using the remote control, the LED output remains off. Why? Why is that? Why is not blinking? Because there is no triggering current. This is a transistor, so we need a triggering current to the base of this PNP transistor. Remember that as we know that the transistor will only switch on whenever there is triggering current to the base. So you can see here, this is a negative voltage. Okay, there must be a pulling of current from 5 volts emitter to the base. So we need to switch this emitter to base at least for 0.7 volts. We need to switch this transistor on. We need the base of this transistor at a low level, or to be grounded in a low level. So whenever there is no remote, we did not yet pressing the remote, there is no triggering current here. That's why the current will not flow from emitter to collector to this coupling resistor, then this stabilizer capacitor, then again this grounding pull down resistor, and then this output LED will not blink as long as there is no current that flows into the emitter to the collector and then to the output LED green. So we need to trigger to switch on this emitter to base. We need only to trigger this or switching this. In order to switch this, we need a low level into the signal pin of this 4830. So initially, the level of this TSOP is as an output. So this is high, active high, or high. There is a current that flows. It is normally there is a current that flows, causing this transistor not to turn on because it is high initially. So in our first instance or our initial analysis, it is on. This TSOP is high, or it outputs a current here, causing this transistor to turn off. When we're going to use the remote, it will receive the signal will be received by this receiver, and suddenly, or this signal pin now will become low, or because we're using the remote, when we press the remote, causing this pin in a low or grounded or zero. So if this is low, 0, low level trigger, current now flows into emitter to the base, switching this transistor, and then biasing this transistor with 15K, and then flowing the current to the resistor, then to the TSOP, then to the ground, pulling it down to the ground. And then since we switching this on, then the current now flows into emitter to collector, and then to the coupling resistor in order not to ring. There's ringing, and then also to stabilize the circuit, and then again to keep it in a low level. Now it is high, so the current now flows here, then causing the output LED to turn on, and it is continuously blinking. So depends on the code of the remote. So in short, in order to turn on this LED, we need to press the remote control, causing the transistor to turn on, to switch on, because this receiver now is in a low level state, or it is grounded. So the current now flows into the emitter base, and then to the TSOP. Then if this switch on, then the current flows into the output side of the transistor, emitter to collector, then to the output. So that's why this LED turns on, and the blinking depends on the code of the remote. Okay, we have now a new circuit, and this time we are now connected to 4017 IC with the transistor driver, and then we have now a new output LED, blue. So before, this is our output LED, the green. Pressing the remote, we can see the blinking of the LED. But if we're going to put the output to the blue LED, we have now this LED. Press it again, any button, off, on, and then the other remote, TCL. This one is Samsung. TCL, on, off. Any button, on, off. So we have now a new output, this blue. Whenever we press the button of the remote, it turns on and off. So this 4017 is act as a latch switch, and the whole circuit, it is a triggering, this is a triggering circuit to the transistor, or to the next circuit we're going to build. So now we have this encoder, and then the latch switch, from momentary switch to latch switch. We have now a new circuit using 4017. So last time, our output connected here, the output LED, which is green, the green. So it is as we have the remote, when we press the remote, we are injecting an on-off signal. Okay, that's why it will make this LED to blinks, because of this train of pulses, in which the last time we connected the LED here. Now, since we have 4017, this is now the input 14. So instead of this green LED connected here, now we have this new output LED connected to the collector of the transistor, blue 2.2K. Input of the 4017 IC is pin number 14. So input, the output of the transistor is going to enter into the input of 4017. 4017 is a decade counter, or known as sequencer. It has sequence. Pin number 16 is the positive. 13 is clock inhibit. When it is grounded, it means our clock is working. The clock is active. And pin number 8 is the ground of the IC. Pin number 13 is grounded, the clock inhibit. When it is grounded, the clock is active. We can use this input. This is for the clock inhibit. And then 4 and 15 must be connected. 4 and 15. 2 is the out. So whenever we have this train of pulses, it will inject this train of pulses to the input of 4017 and causing the output of this BC547, which is a transistor driver NPN type collector base emitter with biasing resistor 1K. We need this biasing resistor in order not to damage this transistor. So when we have this output, it will turn on this transistor, switching this base emitter of the transistor and then causing the current to flow and turning on this blue LED. And then we press again the remote, it will turn off the LED. Press it again, it will on, off, on, off, on, off. So this part 4017 act as a latch switch, or we can call that toggle switch. It will help. It can turn on, turn off using this circuit. Because this is sequencer, it has sequence of number 3 to 4, pin number 3 to 4. When there is on, off, off, and it is on, the 3 and 4 is off, the pin. We can see that sequencer. And when during the 4 toggling, it will reset, going back to the pin number 2. That's why it acts as a latch switch. The latching effect of this IC 3 to 4 sequencing, 3 to 4, then reset back to the number 2 or 3, then 2, 4. So in short, this 4017 act as a switch, because this encoder only works on as a momentary switching due to the supplying or inputting this train of pulses to the input of number 14. And then once this transistor triggers this number 14 input pin of 4017, it will latch the circuit. Okay, we have now the main circuit. We are now connected the relay to control the 220 volts lamp, and we have this power bank as the supply to the circuit and to the relay. And also we have the remote. We're going to plug the 220. Let us now test using the remote Samsung. So we have now the latch switch turning on, off. You can hear the clicking sound of the relay, but we don't have the 220 lamp let us now turn on the switch again. As you can see, we can now control the 220 volts using the 4017 IC with the infrared receiver, with also with this relay. The relay is 5 volts, but it controls 220 volts to the high side. We can also use different remote like this one, or this remote Sony. Any button, we can press any button. TCL. And this remote from online store. So we just press any button for turning it on and off. This is now the figure 2 IR remote control using 4017 to control 220 volts lamp. So we know that we have the decoder, infrared, and then the latch. This one latch. And then to the latch, we have this transistor, which is the driver, relay driver. So to the collector of this transistor connected is the relay, the coil of the relay 1, 2, and then with the parallel clamping diode or freewheeling diode. And to the output of the high side of the relay, we have the common and then the normally closed. Since this is normally closed, normally open. Connected is the 220 volts lamp, which is connected to 220 volt supply, AC. And then connected also to the 220 volts is the common of the relay. Once we have received the signal here, since we already in this area, once we switching this transistor on, it will turn on this LED. Once the LED blue turns on, it also induce a voltage across the coil because the current flows into the coil of the relay. Once the voltage induced as a magnet, or it will attract it will now become just like an electromagnet. It will attract now this moving common contact to the pin number 4 and pin number 3. So this 3 and 4 now is closed. Since we have a second supply of current, current supply, which is second voltage supply 220 volts, and the lamp, there is now a complete circuit. The current now flows, turning this 220 volts lamp to the pin number 4, to the 3, then back to the source. So it will continue to turn on this 220 volts lamp because this common contact is now connected to the 3 and 4 pin, causing this to have a complete circuit here because of the due to the induction of the voltage here. It becomes a magnet, just like an magnetic induction. They call it magnetic induction. Once we press again the remote, since we have the remote here, for example here, and then it will now turn off this LED, causing this common contact point to go back to its original position, to the normal. And the current, there is now no supply, voltage supply to the output, since there is no closed circuit here. 220 volt lamps will turn off. Once we press the remote again, it will turns on, turns off. We can hear the clicking sound of the relay because of this contact, moving the contact, the pin 3, 4, and then go back to pin 5, 4, 5, 4, 5, 4. And what is the use of this diode? Freewheeling diode is used to protect the circuit from back EMF because it produces a large spark or spike, voltage spike to the circuit once due to the on-off of the contact, or the moving of the contact, turning on and off the LED, the lamp, and the voltage. There is a voltage spike developed across this coil, and in order to protect the circuit, we need a diode 1N4007 power diode, so that once there is a voltage spike, it will continues to just to move around the circuit or the current through this coil, and not affecting the whole circuit, just only in this area. So when the contact moves from turning on and off, on off, clicking the sound, it will produce a high voltage spike. So protect the circuit from damaging the circuit, you need this freewheeling diode, so that the excess voltage spike will just continue, the current will continue to move around to this direction until it has no current, until it losing its power. That is the protection diode we need. So it is due to the moving of the contact of the relay that turns this 220 volts on and off. Remember that the bulb is connected to normally open pin number 4, and then one side is to the supply 220 volts, and the other side of the 220 volts connected to the common of this relay, common pin of the relay. Our module now is connected, the supply, power bank through USB. Then this is now the main board, our homemade DIY board. And then the 220 and the bulb is connected now to the relay. So you can see only two lines here for the valve, and then the input also two lines power using the power bank. So we have only two supply and also two lines into the out or the output side. And let us now test the remote. Using the Samsung. Any button we press. And Sony TCL, any button. Oops. Hey. Also this small remote. And then this one. So we can now use this DIY board to control any 220 volts uh, gadget or device or any as long as it is capable of handling 10 ampere. As long it is 10 ampere to 20 volts, we can use this.